Good morning, everyone. I am Jonathan Bryce from the OpenStack Foundation, and it is awesome that you all are joining us for the next couple of days at our first OpenDev event. This is an event that we started planning earlier this year for a couple of different reasons, and what we wanted to do was really have an opportunity to get people together who are working across multiple communities in open source and who are trying to solve multi-dimensional problems in their businesses. And initially, this was an idea that we had that was kind of more generic around just broad open source community at large. As we started to talk about it, one of the things that we found was really an emerging trend that was common across a lot of companies and a lot of these technology communities was the rise of edge computing. And that is our theme for this OpenDev event. And it's very exciting to kick it off. We've got about 200 people registered for the event. For the most part, you're all technical in one way or the other. So this is meant to be a working event. And we're going to hopefully have a couple of productive days here and some good outcomes. And we'll talk a little bit more about what that is hopefully going to look like. To start off with, I did want to thank the sponsors that made this event possible: Ericsson, Intel, and the OpenStack Foundation. All provided the funding that we needed to get a venue and be able to get everyone together in order to have these days. And I also wanted to call out and thank our programming committee that helped kind of plan the topics and really also reach out across multiple industries to bring experts together: architects, developers, engineers, people who are working in this space. And I think that most of you are right down here. If you stand up: Gregory, Andrew, Kandan, Beth, and Pryce is somewhere too. But definitely find them and thank them for their work. They've spent hours over the last couple of months going through, looking in their businesses, talking to people they work with to figure out, what are the things that we need to address. So how is it going to work over the next couple of days? We're starting off this morning with a series of short keynotes that are coming from AT&T, from Intel, Verizon, from Satya, who's sort of the inventor of edge computing as a concept, and also from eBay. And what I hope we can do this morning as we run through, we're going to see some use cases, we're going to see some demos, we're going to hear about some of the people who are already working in edge computing, and hopefully we can get a vision for what this can be and what the problem space looks like and where this is going to go. Over the last 6 months, really, I've seen this be something that is emerging across many industries. I think when people think about edge, a lot of times they think about IoT and they think about telecom. And that's certainly a big part of edge, but it's really only one part of it. And what I've seen is I've seen people who are working in retail who have a lot of locations, and people who are working in manufacturing, people who are working in offshore drilling, people who are doing work in all kinds of industries. They're facing similar problems, and that's really what drove this event. And so this morning, we're going to have some keynotes, look at some of those different problem sets that we want to address, and then we're going to have lunch. And lunch is going to be outside around the corner here. There are food trucks that are going to be here for us to be able to get some great food. And then this afternoon, we're going to be breaking out into 3 breakout tracks. So this, where we all are right now, is level 1. And if you go out towards the entrance where everyone entered, to the left there are elevators and stairs that go up to level 2 and level 3. And so there is a room on level 2 and a room on level 3. And you can see the full schedule at opendevconf.com/schedule. So follow that. We're going to be updating that too as we go through. And if you look at that right now, most of the sessions are in there, and a lot of them have Etherpad links. How many of you have been to an OpenStack Design Summit before? Okay, cool. So most of you are going to be familiar with kind of the mechanics of this. But in each of those rooms, there's a set of a whiteboard. there's a giant Post-it pad, there are screens, we've got ether pads, the rooms are set up in kind of that horseshoe shape, and the goal is to really dive deep on a topic and document as much as we can in the ether pads. We have moderators assigned for the various topics, and we're going to gather all of that information, and tomorrow we're going to come back here on level 1 at the end of the day and review what we covered, what the action items are, what we can go do, and you know, where we take edge from here going forward. Tomorrow morning, we're actually starting out with a 15-minute session that's going to be, you know, very quick and informal. And tomorrow, the afternoon sessions are actually not scheduled yet. Because what we want to do is we know that as we have the discussions today, and as we have our informal hallway track, we're going to come up with topics that, you know, we didn't foresee, or things that come up that we need to spend more time on. So throughout the day, as you think of those, write it on a pad in any of the rooms. We're going to gather all of those, and tomorrow morning, we're going to sit together and we're going to spend 15 minutes. We have 6 sessions that are unconference style that we're going to schedule tomorrow. If there's a topic that you think is really important that isn't on the schedule, or that there's not a good place to discuss it, don't worry. We can fill that in tomorrow. And then we'll have more working sessions, and I said we'll gather at the end tomorrow to go ahead and review everything that was covered. Some other housekeeping items. Wi-Fi information should be on the back of your badge, and one of the things that we're going to be doing tonight that should be fun is just around the corner. There's a winery location here. It's called Wineworks, Dogpatch Wineworks. And we will be heading over there at the end of today for a happy hour from 5:30 to 7:30. So hopefully we will see you all there, and we can talk about what we discussed today and make a plan for tomorrow. So I talked a little bit about how the event got started, but I want to talk briefly before we get into the keynotes about why I think it's important and what I hope we can get out of this. So NFV is something that very heavily used, very heavily discussed and developed on in the OpenStack space now. But that really started in 2014. And a lot of that kind of came out of a keynote that Toby Ford presented in the summit in Atlanta in 2014. And at the time, he kind of talked about the shift that his industry was going through and what they needed to get off of kind of hard-to-change, proprietary, black box systems into something that was more agile, more software-driven. You fast forward to where we are now, over 3 years later, and there is a lot of work that's been done in NFV, and there are a lot of workloads that are being run in that space. But between here and there, one of the things that I think we learned along the way was that we had some false starts with NFV. Toby said, like, this is a vision, I'm putting it out there, but it's going to take a while, and it's going to take a lot of work. And he was right. But I think that one of the things that we sort of missed on early on was getting together developers, operators, architects, getting everyone in the space together to sort of talk about what the goals were, what the needs were, and how some of these workloads were different than just traditional cloud workloads. And as I said, over the last 6 months, I've been talking to a lot of companies who are working on edge computing. And I think that what I'm really seeing in more industries than I expected, honestly, is that the concept of very large centralized data centers is not the only way that they can meet their computing needs. And so we are seeing companies who have definitely large central data centers. Those might be private clouds or public clouds. But they also have smaller computing centers, and they might have several rings of those, kind of multiple layers of computing out to the very edge where you might have small devices. And as I talked to these companies, what I started to hear were different terminologies, different architectures, different approaches. And it kind of, it gave me a little bit of a flashback to 2014 and 2015 with NFV. And what I thought we really needed to do was to try to get a group of people who are working on this together earlier in the process so that we could hopefully shorten some of those cycles and come together around what the goals are and what the needs are and where feature gaps might be. And that's really how we got to this edge focus for OpenDev. And I think that if you think about that problem set of moving from central data centers to more and more computing that's spread out, it makes a lot of sense when you look at the estimates. 10 billion devices that are connected to the internet, and it just continues to grow. There's a lot of estimates. They range all over the place. From 15 to 50. Some people have even said a trillion. I think that is probably a little bit, that's probably farther off than the next 5 to 10 years. But whatever it is, it doesn't matter. We're talking tens of billions of devices that are all generating data, that are generating work that needs to be analyzed, computed, put into machine learning systems. And so, what are the patterns? What are the technologies that people are going to use to attack that? SDX Central just recently ran a survey, and they asked people, as you implement edge computing, what technologies are you going to be using in that? And this was the result that they just released this week. And what I think is really, really interesting about this data is if you look at this, most of these technologies are open source technologies. And that is a big shift from where technology development happened just a couple of decades ago. The other thing that I think is interesting about this is it's multiple different communities. And so when I think about a problem like this, I think this fits very well with something that Mark Collier said in a keynote in Austin last year, where he said the problems we're facing today are too big for any one company, any one country, any one community to take on and tackle on their own. And so an event like this that spans all of these different technologies, I think is really important if we want to be able to put the right implementations in place to solve these massive problems, these awesome problems that companies and organizations are facing all around the world. So for me, I have 3 goals that I would love to see us accomplish over the next couple of days with this event. The first one is to build those relationships that I think sometimes we lacked in the early days of NFV work between the practitioners, the architects, the developers who are building infrastructure software, and let's make sure that we know and understand who's working on this on all sides of the problem. The second thing that I think we should come out of this with is a whole set of documentation around the use cases that we need to be addressing, architecture and deployment patterns that people are already implementing, ideas for ways to improve those, and then also best practices for management, operations, security. When you start to really spread out your computing, these things start to look very different than when you're running a very large-scale, locked-down, physically secure data center. So let's, the people who are already doing this, let's pick your brains, share your wisdom, let's get it documented, and publish that so that we can all benefit from it and we can move things forward more quickly. And then the third area is I'd like to see us triage the needs for open projects. And that's for both feature gaps in existing open technologies, what might be missing, what might need to be built into an existing component like Nova or Kubernetes or Ceph or whatever it might be, Open Contrail, any of these technologies that people are already using in the space. I also want to look at the functionality mismatches with existing open technologies. Let's really be honest about, are we trying to put square pegs in round holes? Or do we have tools that are close and just need a little adjustment? Or are the tools not at all the fit and we need to look somewhere else? And as we do that, there may be areas where we need actually completely new projects, or there may be other projects that exist out there that some of you are aware of that the rest of us don't know about. But really, let's think about the technology, and let's think about it critically so that we can come up with the work that we need to do. As I said, tomorrow, at the end of the day, we are going to all gather back here, and we're going to have kind of a lightning round where we're going to review every topic that we had across all 3 tracks, the takeaways, and hopefully come up with some work to go back to our respective communities and our companies where we can go really make a practical difference around this. In each of the breakout rooms, as I said, there are screens, there are Post-it notes, there are whiteboards. The OpenStack Foundation has staff members that are going to be in every session helping to document and then to aggregate all of that information back up. So lean on them and make sure that we're really getting as much information as we can out. It doesn't have to be pretty in these discussions. We'll organize it later. But really we want to come out with some good, solid information from each of these sessions, and then work that we can go forth and execute on to make this edge vision a reality. So that's all the time I'm going to take to kick it off. As I said, we've got a series of speakers this morning that are going to talk in mostly real-world terms about what edge is today and where it can go in the near future. And then we've got a special privilege to have, as I said, Satya, who is the founder of Edge Computing, who is going to wrap up the morning and show us, hopefully, he's going to stretch our brains and give us some exciting concepts for where we can take Edge over the next decades and how it can really impact our lives. So to kick things off, I want to go ahead and bring up Kandan from AT&T to give us our first keynote. So Kandan.
Good morning, everyone. We are excited to be here, and this is Kandan Kathirvel from AT&T.
I'm Rodolfo Pacheco.
So we're going to talk about what is AT&T edge computing strategy and what is the OpenStack role in it. So Jonathan actually covered that there are multiple technology being used in the edge computing as of today, and there's a lot of questions around, like which fits into a real-world solution. And I'm going to cover the use cases that telco industry is actually looking at, because there's a lot of myth around the use cases when we read the blogs and the news around it. So we're going to actually share what exactly the industry is looking at from the use cases perspective. And also we're going to show a demo of a solution that we're going to take it to production for the edge deployment. And it is pretty excited. And we use OpenStack in that particular solution, and we're going to show that how we are using it and what are the other components we are using to implement that particular edge solution. So before we talk about a solution, I think it's very important to understand the use cases. As Jonathan mentioned, there is a lot of use cases related to the edge computing. And there was a lot of push in the industry that everybody awares of is that to move the workloads towards a centralized data center. So that's where the Amazon, Rackspace, and other cloud providers, where everybody is moving the workload into that. And the telcos, they had a private cloud, which is basically, again, based on centralized deployment. But most of the telcos also had a deployment in the central offices to support the workloads which are running in the central offices. And that actually brought the scale up to like 100 or 200 plus location. But it is not about like 10,000 plus location that the edge use cases really need. So there is really 4 type of use cases that industry is looking at from a telco driver perspective. So the number one is like IP enterprise services. This is something in an existing service today that is a need more scale in terms of like a small data center, which is an edge compute, to be deployed in the central offices and other wire centers, which is pretty close to the customers. So this use case is like, could also take the devices into the customer place itself. For example, today AT&T, we support a FlexWare, which is basically we deploy in a customer premises. So in this context, like the use case is like a lower node startup cost. This is very important because when we try to deploy a large data center, what we do is like, we have a big control plane, what we call as like OpenStack, Kubernetes, and other things what we deploy, it's really bigger, right? So that could not be accommodated in the small deployments, and that is an important use case that the first bucket actually has to solve. Whatever we're talking about the edge computing, the solutioning has to work for the smaller, low startup cost, a small control plane sort of a deployment. The second part is a technology evolution. In the telco world, there is a there is a technology evolution is happening in terms of, like wireless, because 5G is coming up, and wireline access. So everything is becoming a virtual network function, as Jonathan was talking about, like everything is becoming an NFV model of deployment. And this technology evolution really means that, like we have to start deploying the cloud in the cell towers, in the central offices, and it is really getting very closer to the user. The third bucket is like, that is what the very interesting bucket that everybody talk about is like AR, VR, drones, IoT, robotics. These application really requires like a low latency workload processing, and that's where this new business opportunity come in. This is not just a telco use case, because telco is actually an enabler. If you use on a cell phone or use any type of access like Ethernet or any type of internet connectivity, in order for the cloud processing need to be done, like it has to be closer to the user. And this particular use case is that this is a new business opportunity for telcos and other cloud providers to support this particular application. The third bucket is that, like the telco has the real estate in terms of closer to the user, because they are the one providing the access into the internet or any type of connectivity. So that way, like the third party cloud could be deployed in the telco spaces, which is actually already happening in some context. Public providers are already deploying in like central the telco offices. But the context is that like this would extend the scale, large number of scale. So to summarize, there is really a four benefits, like from a telco perspective that telco would get out of this edge computing is that the quality of experience. It is very important that, like this context need to be very closer so that this could be supported from edge computing perspective, the quality of the experience that the customer would see. Either they use AR, VR equipment, or they use some edge application in a cell phone, they get a better experience with that. And the right content at the edge that reduces the backhaul traffic going into the central deployment of the cloud. The third thing is what we talked about, that wireless 5G, that is a decomposing and disaggregate access function. And the fourth one is like a better network resiliency. Now we have like a large number of cloud deployment, then you can have workload deployed across the centralized and the edge cloud, and that provides you the better network resiliency. The other context is like, where does this going to be deployed? That is very important to understand. And there is a really important thing need to understand is that, like there is a specific latency need that applications like AR, VR really requires. And it has to be less than 20 milliseconds. The reason is like when a user is using those equipments, in order to have a very effective way of, like looking at that video, so it has to be less than 20 milliseconds. So where does this 20 millisecond comes down? Like, the device itself would take like a sensor or a mobile device that itself takes like 2 milliseconds. Then you have a last mile, like it could also a customer premise that equipment. And then, like you have an access, which is a cell tower, or it could be a wire center connecting to a Ethernet service. And then we have a telco real estate where that is where, like the telco applications are deployed. So by looking at this context, like there is the edge could be deployed in any of these places. It could be in a customer place, or it could be in a telco space, or it could be in a, like a traditional data center, if that data center is very close to the edge. So if you look at the scale, this is where we really need to understand, like the industry was playing mostly on the thousands and tens with respect to the deployments, but now we're really talking about, like thousands and millions of deployment, because we are trying to deploy something into a customer premise that we're really talking about in like millions of deployments. So that's where this edge scale really comes along. So this is a stack that we have prototyped it, and we're going to take into production. This is completely based on open source, and there is really a two-part here. There's one is like the open source, which is already exist, and the second part is that open source, that something we are developing and upstreaming it already. And in this picture, if you see in the bottom portion of it, the control plane is really, we are trying to run things in a container. Even the OpenStack, we are trying to run it in a container. So there was a question, like what we had to do, can I use an OpenStack today for the edge deployment? The answer is yes, and we are already doing it. And we are actually containerizing the OpenStack components, whatever the needed components, and deploying into the container-based platform. And in the top, you can see that we have a ONAP, which is basically providing an NFV orchestration across the multiple edge location. Then you can also see that components like Promenade, Shippa, Dryark, that's something Rodolfo is going to talk about. And those components are the open source source components that we are contributing to it. Rodolfo is going to share that link, and he's going to show the demo. And in that, like if we are all contributing to it, we welcome everybody on joining that open source. And it is actually also in the OpenStack website itself. Okay.
Okay, so what Kandan was telling was fundamental. We're trying to solve with this demo a couple of the key problems. They're all problems in a sense that are now they're exacerbated, right? We're talking about you go from multiple data centers to hundreds, potentially thousands of locations where you have to manage a cloud. You talk about the fact that those locations are small, so we have to deploy a control plane that is thin. That's the thin control plane. What we've done is we started by introducing OpenStack Helm earlier last year, all the way through Boston. It's now the OpenStack namespace. OpenStack Helm is a way of packaging OpenStack and deployment and life cycle. We demo doing that multiple times, deploying, upgrading, all without interruption to the tenant workloads. But now we're introducing a new under-cloud control plane. It's this idea that you have to manage thousands of these locations. You wanted to do it with zero touch or as close as possible. And you want to be able to manage the life cycle, not only of OpenStack, but what's running below, which potentially is Kubernetes and Docker, the operating system, and some other functions. So that's what this set of components are providing. We have something called Promenade, which is a way of deploying Kubernetes in a resilient fashion. You'll see in the demo that is quite compressed, so hopefully you guys can keep up. We have ChipJar, which is a way everything that's going to happen in this under cloud control plane is going to be exposed through REST APIs. Everything we do will be declared as all the data is YAML artifacts following the Kubernetes notions of there's different kinds of documents that describe servers, networks, links, storage, whatever. We have DryDoc, which is an abstraction to managing the deployment of the infrastructure, whether that's bare metals or VMs. It's a framework. Behind it, there will be plugins. Today, in this demo, we're using Mass. Could be ironic in the future. We have Armada, which some of you might be familiar with, which is a way of managing the life cycle of multiple Helm charts. If you're familiar with what Helm is a Kubernetes packaging manager tool. It's up in the CNCF space. Armada is a level above. It gives you a way of managing dependencies across many, many charts. And then Deckhand, which is an internal mechanism that we're building to manage interdependencies, layering, and other functions across all these YAML artifacts that come into this undercloud. I'm going to go into the demo, and hopefully we'll... so I've added some slides to try to give you context of what's happening, but the idea is you're starting with an edge node that all you need is a first seed host, whether you have hopefully remote access to it or you deliver that initial software as what we deliver is Promenade packaged as a container. Here you're seeing as the container is being built, and it gets delivered to this first node. Promenade has a lifecycle process, we call it Genesis, which will run here in a second. And what Genesis is doing is taking that first node and is going to instantiate a resilient Kubernetes cluster of a single node. And then after we do that, it is going to, again, deploy that under-cloud control plane, all those components that we talked about that are themselves expressed as Helm packages, and we're using Armada to deploy it. Kubernetes itself is running as well on itself. So we have Kubernetes and Kubernetes. And this is just the undercloud. This is just preparing the first server, so now we're ready to deploy this edge node. It also comes with a series of core services like Prometheus and Fluentd. Now, here we're going to see it executing that, and you'll see it come up pretty quick, because I'm sure you didn't want to just watch Kubernetes standing up this under-cloud control plane. Once it's up and running, we now have a way of programmatically interacting with this edge node. Whether it's 1, 20, 4 servers, I can now describe what that edge is going to be, again, through YAML artifacts, which I'm going to deliver through ChipJar through a REST API. And now ChipJar is going to, the undercloud is going to take that and is going to use DryDoc. Those artifacts describe what you want. What are your intentions? What kind of service you have? Are they control servers? Are they compute? Are you bin packing? Are you separating what the servers are for? All of that you describe to these YAML artifacts that get delivered. And now we're going to watch as this stands up the multiple servers in the node. This is all happening through dry dock at this point. It's all API driven, and that's what you're seeing coming up. So dry dock is going to take those intentions expressed through the YAML artifacts and is going to, in conjunction with Promenade, configure, stand up the servers, and is going to automatically, they're going to join the Kubernetes cluster with the appropriate labels. Is also going to configure whatever networking through dry dock. We can do complex networking configurations, MTUs, VLAN assignments, CPU binding. If you're running SRIOV, we can go and configure the virtual functions as a PF. And that's what this is showing right now. Is coming, it's going to show up the nodes being recognized by Kubernetes. And as they come up, you'll see that we also deploy some things like the components of the CNI, which for this demo we're using Calico, also using an SDS based on Ceph. All of this is packaged, again, the same way, it's all cohesive, everything is using Helm. And as they come up, you'll see that it's going to deploy Ceph and Calico components as daemon sets in the right host. And now the nodes are ready. Now we're ready to deploy OpenStack. We said we're leveraging OpenStack Helm, which again is expressed itself to a series of Armada YAML artifacts. We deliver those through the same API that ChipYard is exposing. ChipYard is going to interact with Armada, and some of you might have already seen this. OpenStack will come up on top of this platform. Kubernetes is going to schedule the OpenStack services however we want. And one of the things that we have here is the ability to control at a very fine granular level what kind of resources you are allocating to each of the OpenStack services. And we can even control within each service which functions we want to run. If for some reason there's an agent you don't care for or you don't need, you don't have to start it. Which is part of our contention that this is providing a thin control plane. We can reduce and optimize the resources that the different OpenStack services are using through the overrides that the Armada packaging of the OpenStack services and OpenStack Helm gives us. This is going to come up as it's, like I said, in an accelerated fashion. You saw the OpenStack services coming up, and now we're going to create an SRIOV VM just to make sure it's all working. And here's the VM, the resources, the volumes coming up. And we're going to see, I'm going to log into Horizon. We're going to see how the one Horizon is up and running. We have the servers immediately are properly configured as compute host. We have the VM up and running. And so what we wanted to show you here, one of the things that we deploy is this core set of functions. So like, as I said before, we are leveraging CNCF functions like Fluentd and Prometheus. And we're trying to make the point that because we can control at that granular level the services, we can express the control plane as a service of resources, core, CPU, memory, and maybe, perhaps you don't have to talk about how many servers do you use for the control plane, but you talk about how much resources you require to run in this thing. And potentially spread the control function across the servers, potentially merge the servers so they're no longer for. So in other words, the control planes and the tenant are themselves two tenants that are coexisting in the same servers. For space where you have 2, 3, 4 servers, that might be the right path to do. Here we're just showing you how the Neutron and MariaDB can be running with very few resources. Again, since these are small edge regions, OpenStack itself doesn't require it to be a mammoth of resource utilization to function. And here we had a little bit of, okay, so now we're running these things. We're taking advantage of some of the resilience factors that Kubernetes introduced. So let's pull the plug on one of the servers. We deploy this control plane across multiple servers. So we're going to power off one of the servers. And we're going to see how, even though you lost the whole server, you do not lose functionality or access anywhere. The tenant workload will continue to run. The Nova API that you see there in the bottom, we're pinging as this is happening, will continue to run. The Kubernetes, of course, is not impacted. So the on-the-cloud control plane is still functioning. All of this without anybody having to do anything. Of course, we were pulled the plug ourselves. But the idea here is that, again, trying to reach the zero-touch notion, if the server reboots, so you can remotely boot it, and the problem was one of just reboot this thing, you'll see how the functions that are running on that will come back or be rescheduled on this server that failed. Of course, if you need to replace the server, you have to replace the server. And so here we're bringing the server back up, and we have a few seconds. Again, this is all accelerated. You have ways of fine-tuning the way this works, and if you're not familiar with Kubernetes, the way how quickly it reacts to a node failure, how quickly it kicks things off, how quickly it decides to reschedule things on the server. So there's a lot of configuration you can do to meet your your use case. And this is going to come back up. We'll show you the workloads. We're going to kill a workload in once the server is up. You'll see it'll bring some of the workloads already back into the server, but we're going to kill one of the workloads that was already rescheduled in the other server, and it will come right up in the server that we just restored. And that concludes this demo for the most part. So again, everything we're doing, the stack that we use for this is all upstream. It's been developed upstream since day one. We have people in this room that are collaborating in some of those projects. We don't have a name for the whole thing combined. They're all individual projects. The one that deals with bare metal servers, Armada deals with the packaging and the deployment. So people can partake, use the individual project that meets their needs.
Thank you, Rodolfo. So in the Boston Summit, everybody had a question whether we can use OpenStack for an edge deployment. And here is the answer, right? So we did a prototype, and we are taking this to production. And as I stated, this is all open source. So the part which is related to OpenStack, it's already in the OpenStack project. And the parts which are related to containers, we are trying to put that into the CNCF, but it's all exposed. The codes are all exposed. You are welcome to join on this project. So if the solution is already there, what is extra we really need? What are we going to do in this conference, for example? Right? So there are at least 6 areas that we believe that we need to concentrate on. One is we need to recognize that EC is our #1 goal. The reason is that this is a really evolving, emerging business, and as well as the opportunity for all of us, not only the telco industry, but also for the open source communities and all the enterprise. So we do really need to realize that this is really needed, because this is going to be the future of cloud computing. The second part is that zero-touch provisioning is a key, because that's where we are trying to show here that, especially when you're trying to deploy in 10,000 plus location, you really need to make sure that, everything can be automated. So that's what we are trying to attempt with respect to that prototype and the open source, what we are trying to do. And the support massive scale, this is also very important, because when we talk about 10,000 sub location, the whole orchestration, the whole systems control plane need to support that scale. And support modular deployment, this is very key. The reason is that we don't want to actually install every part of the thing we used to deploy in a large data center. We really like to deploy the only thing needed. Even this is applicable for OpenStack, or this is even applicable for any other control plane components we would support, because we like to have it thin. So in this prototype, we really used the whole thinning down of the OpenStack, really running it as it is, but in a container, in a small set of containers in a local deployment. But we also should concentrate on, what could be done regionally, placing regional placement of OpenStack and try to manage the edge devices. And another thing is support new technologies faster. This is very important, because there is multiple communities that are trying to work on the edge. It's very important that we all coming together, because there are things which are developed by other vendors and communities. We need to adapt to it. For example, GPU, FGPA, and there is special hardware that need to be supported on this. And also, it's really important that we collaborate with other communities from an OpenStack perspective. For example, CNCF, ONAP, and to provide a end-to-end solution. And I think this conference is trying to attempt that. And the last one is support integration with edge technologies. That's what the point I was trying to mention, is that we really need to work together with other communities too, to really support the cohesive solution. Thank you for the opportunity.
Thank you.
Thank you, Rodolfo and Kandan. So next up, we will be hearing from Ahmad from Intel. And I'm just going to switch these slides over here. All right, so yes, help me welcome Ahmad Susu from Intel.
Thanks, Jonathan. Hey, good morning. Okay, so thanks, Jonathan. And first thing I want to start with, I want to thank the foundation and Jonathan for putting this together. I think this is, when Jonathan called up and about, hey, are you guys interested in sponsoring and participating? And it's unfortunate that we didn't know about this earlier because I think, you know, this is exactly the type of a summit and a conference that we need, and I'm hoping that this continues. And Jonathan, we would be gladly continue to support you in sponsoring and doing this, and you know, be more active, obviously, as we do. So the one thing that I'm not going to spend, I usually spend time on the merit of open source when I talk about things like this, and obviously here I'm not going to do that. We assume, you know, everything we talk about is open source. You know, given, particularly in this space, whether you're talking about the data center side of it, where 9 out of the top 10 data centers are running on open source and Linux and OpenStack and so on, and the same when you look on the client side, the vast majority, the billions of devices, again, it's all open source, so I'm not going to spend much time on that. What I will spend a bit of time on is talking about how we view things a bit at Intel, and just with some of it with my personal views on edge computing, which would, you know, we feel that it's really important to put that entire picture together instead of just data center and IoT and so on, the networking and so on. And I will spend time talking about a few of the projects that we're working on in this area. And actually, you know, I looked at how many projects, open source projects, that we at Intel, and probably mostly in my group, are working on that are relating or focused on some part of edge computing. And there's literally, we counted over 100 projects. So the projects that we chose that, hey, I'll just talk about these, are things that I think that obviously all of them are important, but I just want to make sure that, you know, this is kind of a glimpse of some of the things that we're working on, and we're hoping that obviously everybody joins us in, you know, in maturing these projects and so on. So, okay. To start with, we do feel that everything is really grounded in the data. So if you look at all of these statistics, whether it's the 50 billion or 200 billion, but we know that there is going to be billions and billions of devices and billions of connected sensors. And all of these are what differentiates these from just being a dumb embedded device, is that they're connected and they compute. And they generate lots and lots of data. If you look at a connected plane, at a smart hospital, at, you know, an autonomous driving system, whether it's a car or a drone, it generates just a massive amount of data. And that data needs to, that data is kind of, is almost the center of this entire structure, where, you know, it needs to be processed, it needs to be transmitted, it needs to be acted on in some form or another. It needs to be stored in most cases, and that is what is driving, you know, the need for this completely different infrastructure that you know, that all of us are working on, and all of these communities that, you know, that's been talked about so far. And obviously, not all of that compute can happen, as, you know, in just thinking back only 5 years ago. that, oh, all of it happens on, on the data center. That's just not how it works. The amount of data and the amount of compute that needs to happen forces things to go out to the edge. And this is really an important difference between today's world and only 5 years ago, when those connected those connected devices that can really compute really were not much into existence. And these things, this type of computing and this type of infrastructure really will transform economy. So if you look at, like, there is a bunch of examples here. You can take, I think the best example I heard the other day is about cars, just updating software in cars. So just creating the structure and figuring out how to safely and securely do an over-the-air upgrade for the complex, like a software-defined cockpit in cars of like like 2-3 years down the road. That by itself would save $35 billion for the car industry. Imagine, we're talking about just one, almost like it's an afterthought, that would save this amount of money. So this is the value of that software and all of these things that we talk about. It is really, really important because it will transform the economy, and it will transform where companies are able to spend their money and where they're able to spend on. And this is, from car to cloud. This is, this is the classic example, because it almost, the car thing and autonomous computing in general just really encompasses almost every aspect of this, from the need for the cloud and what the cloud needs to do, and how devices connected, how devices connect to a device, how devices connect to a cloud, the safety critical systems that are needed, the network infrastructure, whether it's 5G and so on, that needs to get set up. So all of these things get encapsulated, almost like one engineer describes it always as like, look, the car itself really becomes, yeah, it's an edge device, but it's also in of itself is a data center that's just on wheels. Okay, so the challenges of edge computing, and these are like, you can go down the list of like what, whether it's orchestration, containers, databases, functional safety, and I'll talk about a few of the projects that we're working on in those areas, but that list of things that we need to work on is actually quite long. And so let me just give you examples, just run really quickly in the couple of minutes on things we're working on. Clear containers. So containers are great, and what's so great about containers is like they're fast, they're quick, you can do things like really, really quickly, you can bring up an app, kill the app, like microseconds, works great. Virtual machines are great. Virtual machines are very, very secure, but also, they're a bit slow. So with the clear containers, what we try to do, which is a perfect, is a perfect example of things that we absolutely would need on the edge, is to bring in the security features of virtualization of things like the VT instruction set, and make that behave and act like a container. The speed of a container, the being able to tear it up and tear it down, and so on. Open source on, I think, on clearlinux.org now. We're still, a lot of these projects, by the way, kind of starts organically, and we're still now in the process of trying to figure out, okay, like where should we open source this project? Where should it go, and so on. Great, just like a lot of people who participate in them right now. And this is one of the things that we, as I talk about these, if any of you have ideas in terms of like, hey, how can we, where should this project be? How should we govern it, and so on, we're completely open to all of those discussions. The lightweight orchestrator, aka Chow, as the engineers call it. So this was envisioned initially as a super lightweight Orchestrator that is very, very, very fast. Performance was very important. But the other thing that was also super important to us in Chow is that it is secure, and it is it requires very little intervention for it to come up. So it's what we call zero configuration. And so this is another project that we have up there. Functional safety. So, and in this regard, we're talking specifically about safety critical Linux. And by the way, we completely invented this term. We have no idea if this is, I don't think there is a project now. We've done a lot of work on it. There is a good understanding of what a safety critical system is, but all of that has been centered around microcontrollers. So like, yes, sure, you can take a microcontroller, you can put on it, a system like VxWorks or like a real, like very, very small, almost like a loop operating system, and make it, functionally safe and pass functional safety certification. Can you do that on an industry type strength operating system, which is what is needed in order to support all the use cases that everybody talks about? You cannot just put any operating system on a plane or in a car that actually does things autonomously without having to comprehend this. So very exciting projects that will need to figure out, we collectively need to figure out how to do it and so on. Time-sensitive networking, again, same, I mean, the concept is probably all of you are familiar with it. It's just like on an end system, you do need to be able to have the real-time properties of but over the network. So I'm out of time, so I'll finish with this slides, end-to-end solutions. So this is really, really important. And and this is why, I personally and all of us at Intel were so excited when the OpenStack Foundation kicked off, this is that for the first time, we will be talking about end-to-end solutions. Solutions like incorporating both the data center and the devices and the network in between and how they connect, because these things really do need to comprehend. A device needs to figure out how to connect to the cloud, and device need to figure out how to device-to-device interconnect, and we have multiple projects around all of those type of areas. But all of these things need to get figured out. So thank you very much, and thanks for the invitation, and thanks for your listening.
Thank you, Ahmad. All right, do another switch over here. Next up, we'll be hearing from another user that is implementing this today, and that is Venkatesh from eBay. So let's welcome Venkatesh.
Good morning, everyone. I'm Venkatesh from eBay. So today the topic is going to be accelerating user experience with edge computing. I'm not going to be talking about how we did OpenStack with Kubernetes integration. Some of my team members spoke about this in our Boston OpenStack conference. So here we're going to take about a specific use case and see why we did it and what are the results of that. So this is all the topic is going to be today. Why we did, what we did with that, and how we did it. So just to answer these three questions is going to be the goal of it. So let's start with the why part of the question here. So for us at eBay, we are very fanatic about user experience. So it's the industry-known stuff. A faster page or a faster application makes customer really happy, which means increase in GMV, gross merchandise value, which is more money. So more than that, we kind of spent last year looking at the full stack to understand what is happening. Why, we are around the world with a few hundred million users every day, getting billions of hits a day. It's pretty one of the heavily trafficked sites in the world. And we've been trying to say, OK, how can we go to the next level of making our site really, really faster? What is that thing that's stopping us? One thing we discovered is being much, much closer to the user is very critical. So the question comes up is, hey, there is tons of public CDNs. Why can't you just use one of them? And that should solve all your problem. So we'll show some data where we could actually augment them even better for specific use cases. So as part of the analysis, we did a bunch of analysis starting all the way from the server-side backend, moving forward to the browser level, looking at IE, Chrome, Firefox, and trying to see how the rendering engines work, a bunch of those things. So we're not going to talk about many of those stuff, but very specific use case. So this is the graph. It's always interesting when I have to remove all the X and Y axis for my legal thing and still have to explain this graph. So this is a bunch of data we collected from millions of users over a 4-day period, a 5-day period time. So the blue line that you see in the bottom is the volume of traffic. As you would say, the volume goes up and comes down every day. The peaks kind of vary in the heights. That is the nature of our user experience, or the user accessing it. And then you see two lines, the red and the yellow, or the orange. So the red one is where we are not using any CDN, and the orange line is where we're using a CDN. So people will say, hey, this looks like a backend server issues. You guys may be overloading on your server backend. What this test actually does is very simple. It's actually fetching a very small image from the browser. So this is something we use something called a RUM, real-time user metric data. So when a page is loaded, when we find that the user is kind of like pretty much done with accessing the page, or it's not going to impact the user experience, we would download a small file, like an image, in the background without impacting the user experience. And we were measuring all of them using nav timing APIs and a bunch of those things. So to actually augment it, this is time to first byte. This is about telling how much time it took for the browser. So this is a client view, for the browser to see the data from the server. So then if you look at the actual response time, this is about downloading entire stuff, the CDN does help. Like if you see the gap between the orange line and the red line, yes, CDN do help. But still, there are little kind of like spikes during the peak time. We want to make sure that we provide a very, very consistent experience to our user. We don't want it to be faster at one part of the time and be slow at other part of the time. So what do we have to do? So the answer to that is, as I mentioned earlier, to get closer to the user. So did I go? OK. So here's one of the example, which we kind of found in the field. This is very interesting. I'm not saying all of them are like this. This kind of shows about the variability in the network path. So this is one of the capture we did from one of the synthetic locations to understand what's happening. It was very simple. We're trying to do a kind of like understand the user experience from Telstra in Australia, Perth, to one of our services. So this was not going through CDN, but we're trying to go just across internet. What you would see fun is like it starts from Perth, goes to Adelaide, goes to Melbourne, goes to Sydney, and then goes to China, goes to Germany. People could always say, hey, this is a routing problem, you guys could solve it. But this is not a consistent problem. The issues comes and goes away, right? We were lucky enough to capture one of this. We were doing a lot of other captures, and we did find one of them. So some of these are the kind of the erratic spurs that's kind of causing those little spikes for us. So how do we solve this? The question is, we want to get much, much closer to the user. When we get much closer to the user, then we have to be, it's kind of going to be very expensive, both in terms of computing and also in terms of real estate. So we have to be much, much efficient in terms of running our applications there. OK, so what did we do? So what we were trying to do was very simple. So this is our page. And as you would see, there is a first HTML call that we make back to the origin. The call actually goes to the origin for a few reasons, like experimentation, tracking, a bunch of other things that happens with it. So in that, we are trying to see if we could accelerate that part of the flow, then the rest of them could be actually accelerated along with it. Every millisecond we save on that is going to actually contribute to the rest of it for us. So as you would see, this is from one of the capture. We found that the time to first byte for the first one of them is 220 milliseconds, which is like really bad for us. We are trying to make it more optimized. OK, so we did a bunch of things. I'm not going to talk about all of them, but only the one that's in the yellow color. So we did a lot of SSL optimization. We did TCP optimization. And then the last one is an application level, which I don't think we have time today to go more into it. But that actually gave us a leapfrog approach, maybe for another day. So what we're going to talk today is more about reduced variability in the network path via internet. So we've been looking at it. We have users across both desktop and mobile. So for the first three of them, it's almost the same. Whatever we do for one applies for most part for the rest. But the caching is very different, which is a different beast to handle altogether. When I meant caching here, I'm not meaning caching an image or a JPEG or a CSS, any of them. It is about caching your dynamic data at a very rapid pace. So OK, how did we do it? Okay, so this is a very simplified view of it. So today, or earlier, the way it used to work is the user would go to a CDN proxy, and then CDN proxy would come back to our origin just over the internet. The thickness of the line does say the latency and the bandwidth of what's available. So as you see, before the bandwidth between the user and CDN proxy was high, but CDN proxy to us, because of the latency and the paths it took, we found that a lot of time it was varying. So we want to do something very simple. We want to drop something closer to the CDN proxy or closer to the user for different reasons. And as you would see, the black lines are the lines over the internet, and the blue line is over our backbone. And you would see that we actually reduce a variability of path. So we are reducing that, OK, the path that can vary is being shrunk a lot. So what this provides is a huge incentive or huge benefit for our user experience to our end users. So let's see what happened. So this is the result. So the green one is an hybrid, which is using both of them. As you would see, there is literally no peaks anymore. We kind of removed the peaks out of it, which means we are providing consistent user behavior to our customers, which is very, very critical for us. Like, irrespective of the platform, irrespective of the place in the world our customers are, they should have best possible experience. So as this is the time to first byte, as you would see, it has reduced it, and this is pretty good for us. So how did the entire response work? So we actually did even better with the response. Downloading the entire content also kind of got accelerated by doing this method. So if you see, the green line is the hybrid thing what we did, and the yellow one is a CDN, and the red one is going directly back. As you would see, we not only made it better at TTFP, but also downloading the entire response time. This entire response is not a page load time. It's for downloading the entire HTML so that the rest of the content can start downloading. So this actually has helped us to move much, much faster. OK, our lessons learned. Measurement is key. There is a lot of synthetic measurements you could do one of, but we find RUM is the best. And the measurement, we built a huge framework where we'll be able to kind of tune it up in terms of make real-time calls to it, be able to pull a lot more data out of it. So do invest in RUM, which is very, very important for you guys when you go into the edge, because we are going to the edge for the reason of making our user experience better. So we should really know how our users feel it, not how a machine sitting in a data center experiences it. There is a big difference between them. So RUM is the best. Next one, designing software stack for edge. This is very, very critical for us. We are a pretty big OpenStack shop. We run one of the big private cloud as well. So a lot of time the discussion comes between ourselves and the infrastructure teams about cattle versus pets. So when I have limited computing power, I can't have this argument of cattle versus pets when I go into my edge. Edges are going to be much, much smaller footprint. So it's somewhere in between, or it's mostly pets. What it means is every CPU cycle matters for us. We cannot afford to waste any CPU cycles or memory out of that. So it has to be fully optimized. So we don't run VMs. We run on containers. So in a Boston earlier OpenStack conference, the team introduced our contribution between OpenStack and Kubernetes called as TESS project. So, and then security and operations are part of the design. When you go into the edge, you're going to be susceptible to DDoS. So, which means you need to be able to solve them. So security and operations are not after the fact. You cannot take it for granted, and you actually have to rethink how you do it. Operations at edge is very different. So there's a macro and a micro picture. This is a very interesting thing for us to talk about. The reason is, when early on we started discussing about it, people are thinking about how much computing power can I actually stuff in my edge without having to do other things. The question is like, OK, can I use, how about for security? How about for other aspects of third-party appliances or containers I could do? The question is, some of the problems you could solve from a macro picture rather than from a micro picture. During DOS attack, you could figure out how you want to route the traffic even before it hits you. So don't always try to solve the problem at a micro level. Also, there are problems you could solve at a macro level, looking at the entire architecture. And the last one is failure modes. The failure modes are way, way different. When we're building data center, it's much different failure modes comparing to edge. You'll be exposed to a lot more gray failures. The gray failures are very hard to detect and troubleshoot, and that's where measurement comes in place, because you might find for the same user in the same network, one of your pop is doing awesome, but the other pop is not doing that great. So RUM is your best friend who's going to come and rescue us. So these are the lessons that what we learned in the process. And this is a journey what we started earlier this year. We are taking baby steps. We are in a much primitive stage of it. We'll be sharing more and more as we progress. And to summarize it, Edge is actually helping us to make our user experience better, which we value the most, because our users should have the best possible experience. And when we start doing it at the edge, the dynamics of what we used to do is changing a lot. And OpenStack and Kubernetes are things that what we're using for most part. And that's pretty much from me. Thank you.
Thank you, Venkatesh. I love what you said about your goal is to get closer to the user, closer to the customer. And I think that's a great way to summarize what a lot of people are trying to accomplish here. So next up, we have a demo from Beth from Verizon. And we had a little bit of trouble with some of the video stuff early this morning. We were doing the setup. So we're actually going to now become an edge node of, of Verizon's office so that we can peek in and see this demo from their network. So help me welcome Beth. And,
run from there.
and good luck with your demo.
Yeah. So yes, this is truly going to be an edge experience. So first, I'm going to talk a little bit about what we did and how we got to there. So when and of course, it's Verizon. Legal has to tell me what to do. So, so who am I? I'm one of the product managers for the company, and this is actually my second product for Verizon. The first one was called Secure Cloud Interconnect, which was one of the which connects private networks to cloud providers, and so that was such a success they gave me this one. So virtual network services. I'm going to start with a little bit with the vision of what we did, and then move into how we did it, and then a demo. So literally, we were starting from nothing. So massively distributed cloud wasn't even a word when we came up with these ideas. And what we said is, okay, what we need to do is software-defined networking. We have to embrace that. That's the future. We know that. But what is software-defined networking? How does that translate into actual products? So that's the trick, right? And what we've discovered over this last year and a half journey is that there's a couple key elements that really need to make it work. And I'm looking for this group here to really help forward these elements. So one of them I know that has been mentioned earlier is orchestration. Orchestration is key, but it's not just orchestration within the within the data center. Orchestration across the network. I mean, that's much harder. I mean, latency becomes a serious problem when you have your core information sitting in a data center in Texas and you're trying to deploy out to an edge device in Sydney, Australia. So there's some physics involved, and we need to address those types of issues. And the architecture is really important, and I know we're going to have some sessions about that later, and I'm really looking for sort of feedback and some real brainstorming around some of the things that really need to make it work. So networking as a service in the real world, that was kind of the vision behind this whole product. So we started, and so this is a diagram I did about just close to a year and a half ago, which was kind of sell internally. Okay, this is what we want to do. So we wanted to be any network, any location, and connect a variety of network services. I like to think of it as a portfolio. So we have to figure out how to do that. So this is my little diagram. I did got to start at the back of the napkin, or actually in this case a notebook, and that got turned into reality. So this is actually the basic architecture behind the service. So zero-touch provisioning, essential, a really good portal experience, which we're going to do a demo in a few minutes. And of course, the orchestration. All of those elements come together to really deliver these services. Conceptually, we want to be able to stand up a service in the cloud and also stand up the same service out at a customer's edge. I like to say the cloud providers have it easy. They don't have to deal with the network. So, so what we did is we did universal CP using OpenStack, and we crammed it cloud in a box, right? So we used Kubernetes to, or sorry, actually we didn't use Kubernetes, we used Docker to get that small footprint. Again, these boxes out at the edge are going to be small, and they're getting smaller. Right now, we don't do it in a Internet of Things box or device, but that's where we're going with this. So obviously, it has to be really light footprint. And right now, OpenStack, we did manage to cram it down to 1 core, but even smaller would be, that's a goal. And you have to decide, well, what is out at the edge and what is back in the core, and how do they talk to each other? Particularly around, again, latency is a problem if you're sitting in the middle of the ocean and you have a device sitting on a ship. And then we also built the Hosted Network Services platform, which is locations around the globe that have the same elements. So that allows us to use orchestration tools in both locations, and give that valuable customer experience that it has to be the same in all locations. Orchestration, it's all about it. So this is a quick diagram of what we use. We use the Ericsson's Cloud Manager in combination with Avda's connector out at the edge, and then some special sauce that we did in between to put them all together. And we also, based on APIs, the idea is that we will expose some APIs to our customers who are asking to be able to access the information, the reporting on their own systems. So here's just a diagram of the workflow. And by the way, guys, this is not easy stuff. There's a whole lot of complexity to operationalize this. It's not just the technology, it's just working with all the operations people to get all this stuff to work. Just explaining the basics of cloud computing to operations people that aren't used to this is a challenge, right? I ended up doing about 50 hours of training to the operations people just to get the idea of what this product was about. So here I'm going to do a quick product overview, and then we're going to go into the demo. So the product is, I like to think of it as a portfolio. So we ended up going with name brands, so all the traditional brands that you're familiar with. That was actually a challenge in itself, talking to all the vendors and explaining what we were doing and getting them on board. OpenStack did help. And this appeals to our customers, because we can say, oh yeah, the security you're using, you can still use the same security system, and it's going to look the same. It's just going to be virtualized. So that's resonated with our customers. And as you can see, it's a framework that allows us to add additional services over time. So we're in the process of rolling out a unified communications platform on this, and I know there's other platforms in the future. And since we've built this platform, there's a way to literally create a marketplace for our vendors going forward. Here's just some high-level diagram of some of the deployment options that we can do. So we have it out at the customer site. We have the hosted location. We have customer data centers. We're moving it out into the public cloud as well. We actually just announced the availability of the first virtual network service within AWS. That's with Viptela. And there will be more coming. So really, we are smearing our services across all the different possible ways you can do it. So here's some pretty pictures, and now we are going to move to the WebEx magic up there. And Rakandu, my coworker, is we're going to be running it from a WebEx because we had to run it from within the Verizon network. So guys up in the booth, start up the WebEx. There we go. Okay, there we go. So what we're looking at here is Verizon has the VEC, or the Verizon Enterprise Console, which is what we share with our customers to allow them to manage their network services. This particular platform's been around since 2009, so it's been a while. But the nice thing is we're adding additional features over time, and so now we are in the process of adding the virtual network services product. So Rakandu, if you could launch the virtual network service piece. So here we're coming into the, and by the way, guys, this is live. This is really live. So we like to live on the edge. So what we are looking at here is the home page. You can, as you can see in the corner, it says you can add widgets, so you can modify this to your choice. I'm not gonna, not gonna make any changes now. But let's, so it shows what services are available. This particular one has one showing, but as you can see, you can drill down. So if you could click on the, I think if you click on that, it does show. Yep. So we're drilling down into the service here, so you can see what's on there. So it looks like it's security, and so this is a universal CP. So this is actually a box, and it has Fortinet security, and what's the other thing? It's hard for me to read. And it says what the service package is. So as you can see, it's complete. So what we sell to our customers is core, essential, core, and complete. So that's a set of features, so they don't have to always buy everything. And then the capacity level is set to small, and it goes. So small starts at 10 megabits per second, and it goes all the way up to 2 gigabits. And again, so you can match it to the connectivity of the product. Resource allocation, let's go into that. So you can see this box, has the Fortinet on it. So that's using the CPU, so you have information about, what's going on with all of your boxes. This happens to be just one, but you can really drill down into the details here. There's also health, right? So it shows how it's, so this shows that the CPU utilization, and so again, it gives you real-time feedback about what's going on. And as you can see, orchestration and rules, that's coming. But right now, this is mostly reporting. You have a way of setting up alerts, so you can add alerts, and you can track your orders. So yeah, I don't think that actually has any orders in there. Oh, it does. Okay, good. So this is just showing all the different orders that are in process in this system, and you can see it has all the different information about that. So one of the things we do is we want to make sure that if you place an order, that it will actually fit on the box. So this is a way so we do a mechanism that validates that there's enough room, and if there isn't, we can ship another box on the edge. That doesn't apply in the cloud and the hosted environment, of course. So Rakandu, if you could switch to showing the policies. So we're going to go into a policy section. So what we've added is the ability to change policies throughout with your software-defined WAN. So bear with us. Okay, there we go. So this is, we're going to go into the SD-WAN policy management component. And this is, so this has got a few more sites here. And it gives you information about what's going on. This happens to be Viptela SD-WAN, but we also have it for the Cisco IWAN as well. So, so let's see. So we have a list of the policies that are available, and so this is the SD-WAN Viptela, as you can see. So you want to show how to create. Yeah, okay, let's edit it first. So here's one that's for Yahoo, so you can, I'm not going to go into details of how SD-WAN works on the here. but you can go through and you can pick which applications and then give them weighting and also which path they'll go through to optimize the performance. So this is all policy management. It all can be done from this console, the Verizon Enterprise Console. So here we're adding one. You can create groups. And now all of these will go out to your specified locations. So you might put it in 20 locations or 50 or 100. You might put it in half of the locations. Really, this policy is very flexible, and this is all done from here. So with that, so let's say we have an update here. So, and there we go. We have updated the policy. Yay! So with that, I thank you. And just a couple closing comments. I really am happy to be here. I think this is a fantastic opportunity for us to really dig into what's needed to really do edge computing right. I'm really glad that, unlike I lived through the beginning of OpenStack, where it was a bunch of developers, and I remember showing up at the first conference and saying, "Oh, I'm a user. Where's the documentation?" And so this is a great start. Just getting the users, getting the developers in one room to begin with. So with that, another thing is my manager said, please work on defining some metrics. So that's my plug. Excellent. So, Jonathan.
Thank you, Beth. That was awesome and very brave of you to do that demo. We had not actually gotten that working before we started, and Lauren said that she heard some of the crew going that this is going really well for a rehearsal. So. All right, so we have one more speaker now, and as I've mentioned a couple of times, he's really the thought leader around the whole concept of edge computing from Carnegie Mellon University. So it's awesome to have him here today speaking to us. So help me welcome up Satya from Carnegie Mellon.
All right, can you hear me loud enough? Good. So thank you very much, Jonathan and Mark and the rest of the team for welcoming me and inviting me to present. Wanted to share with you the lessons that we have learned over about a decade on why edge computing is not just an incremental technology, it is truly disruptive, okay? So hopefully what I have to share with you will stretch your minds, help you see the potential far beyond just next year or the year after, but in terms of truly strategic thinking. So there are really 4 fundamental reasons why edge computing is a disruptive technology. First and foremost, it is the only way to cope with physics, as Beth was mentioning, if you want to offer highly responsive cloud services where latency can be controlled and kept low, there is really no other alternative. And let me put it this way. Deploying 5G without edge computing is a waste of time and money. That the low latency offered by 5G is going to be completely swamped by the tail of the backhaul if you do not have the processing happening close to the edge. A second, independent of latency considerations, the cumulative bandwidth from a large number of sensors, especially think of video sensors. Video cameras are cheap. They're on cars, they're on drones, they're on people. You can put them on pets, right? Imagine what the total ingress bandwidth of a city like San Francisco would be into the cloud if all that video had to be streamed live. So if you're ever going to be able to use video in real time with processing, then you're going to have to move the compute much, much closer to where the capture of the data is happening. And everything I say about video is also true about other kinds of sensors. It's just easiest for us to think about video simply because it is such an easy example to relate to. The Internet of Things is big, and there are companies like Nest, now part of Google, and many others. Intel has an entire IoT division. So the belief is that every home is going to become a highly sensed and automated environment. However, there is pushback because there's considerable concern that releasing all that data to the cloud is losing control of privacy. And so it turns out that the ability to have a privacy firewall under your control, which runs software in real time, examining the data that is being released, and possibly alerting you, possibly redacting the data, etc., based on your policies, is an extraordinarily valuable thing to have. So just as a network firewall keeps bad things out, a privacy firewall keeps sensitive things in. And so that role is something uniquely a capability of edge computing. And last but not least, the more dependent we become on the cloud, and cloud computing, by the way, is not going to go away. It's going to get bigger and better, and hopefully edge computing can make it even better. And here's how. The more dependent you become on the cloud, the more pain you're going to feel when you cannot get to the cloud. The ability to have fallback, so that if there's a transient network failure, a denial of service attack, or some other similar situation, is extraordinarily powerful. So the ability of an edge node close to you to temporarily offer you fallback cloud services, just like a uninterruptible power supply gives you backup power for a few minutes if the power is transiently down. That kind of use is an extraordinarily valuable use of edge computing. So we have been exploring all of these, but Jonathan only gave me 25 minutes, so there's no way I'm ever going to tell you about all this exciting stuff. I'm going to focus on just one, okay? What is it that you can do with a lot of compute accessible at very low latency, okay? I'm going to have to use a word to describe these edge nodes, and I'm going to use the word cloudlet. It's a nice name, it's reminiscent of cloud computing, fits OpenStack perfectly. So my vision of a cloudlet is a small data center. I love the term cloud in a box that I think Beth mentioned. It's exactly right. That's what we call a cloudlet. It could be one wireless hop or a 4G LTE hop or a 5G someday, maybe an additional LAN or fiber hop, so that it doesn't really have to be in the access point or the cell tower. It could be a little deeper. But the important point is you have one hop followed by almost no further delay. It's multi-tenant. I think at the end of the day, for the widest possible use, you have to have the same kind of usability of those edge resources that you have of the cloud. Once you have multi-tenancy and multiple users, like all of you in this room should be able to use a nearby cloudlet while you're here. That requires safety and isolation, and typically virtual machines are the best way to provide that. Now, you may on top of this, for scalability, have Dockers within VMs, but our vision is the lowest layer is virtual machines with Docker as a layer above. Now, there are two things you do not have to worry about in cloudlets, and this is important. we assume that the cloudlet has a sufficiently large source of energy. Either it's plugged into the wall, or for example, it's in an automobile. So if you have enough energy to move multiple occupants at highway speeds, you don't worry too much about how much energy your edge node is going to consume, okay? On the other hand, if you're a wearable device, you don't want to carry a lot of compute with you, you offload to the cloudlet, which is doing the compute. Similarly, if you're a drone, it's easy to put a video camera on the drone. But to carry along and compute that is powerful enough to do real-time video processing of that captured data, your drone would have to be really powerful and large to do that. Much simpler to use a small drone, transmit the video to a cloudlet, which doesn't have those constraints. And of course, things like weight, size, heat dissipation, all of these things matter once you start talking about wearable devices, handheld devices, drones, etc. So these are the constraints that you're freed from by using a cloudlet. And I will show you in the next few minutes how this combination can be truly disruptive. So we assume a deployment picture that looks roughly as in this graph. You have the cloud world today, OpenStack prominently shown here. And I would love to see the cloudlets at the edge all running slightly extended versions of OpenStack. And in this afternoon's seminar on infrastructure at the edge, I will share my thoughts on what that could potentially be. As a number of previous speakers have said, it may also be necessary to strip down OpenStack in order to suit the edge. So I think of it as OpenStack minus minus followed by plus plus. Okay? You have to strip it down a bit, but you also need some new functionality that is specific to edge computing. So the way forward, I believe, is a very huge opportunity for OpenStack as an open source project, and people are familiar with it. It's already used in data centers. There's an enormous amount of cultural knowledge about OpenStack that can be leveraged to make edge computing accelerated and successful. So a quick question. People often ask me, you know, today's internet works. Does latency really matter? The answer is yes. It's documented in a number of measurement papers that we have published. Let me just show you one example. This is an augmented reality example, not written by us. It's actually written by a team at Intel. It runs on a front end that's a smartphone. You capture an image, for example, a photograph of San Francisco, ship the JPEG image to a backend that's running in the cloud or a cloudlet. It does computer vision, recognizes the buildings, annotates this is the Transamerica building, this is Coit Tower, etc., and sends you back the labels and the coordinates, which you then display to the user. So the user experience is you just hold it up and the annotations appear for you. So imagine you do this completely on board the smartphone. What I'm showing here on the x-axis is the number of milliseconds it takes before the user sees the annotations. And the vertical axis is what fraction of the responses come back. The perfect curve would be a step function at 0. That means it's instantaneous. As soon as you hold up your camera, it appears. This is really sluggish because you're doing the computer vision on board the smartphone. Now, what happens if you offload to Amazon East, which amazingly, from Pittsburgh, is only 6 milliseconds away in Virginia? Okay? That's the picture that you get. If you offload to Amazon West, which is out here, you can see that the cross-country internet latency kicks in. Going to Dublin from Pittsburgh is almost as good as coming to the West Coast. It's only a little further. Going to Asia, Amazon Asia, is a lot further. What can a Wi-Fi Cloudlet do for you? That's what it can do for you. It is much, much closer than even Amazon East in terms of the user responsiveness. What happens if the first hop is 4G LTE rather than Wi-Fi? 4G LTE has a longer end-to-end latency, and so you see all the curves shifted, but the relative picture remains the same. Now, this is just one example, but those papers that I have listed have plenty of other data for many other applications that show without any question, for interactive applications, this is big. So that's user experience. But there's another aspect of mobile computing that every user cares about, which is battery life. For that application that I just showed you, this is how many joules of energy are burned on the mobile device while the operation is performed. So if you do it all on the mobile device, that's the complete computer vision compute. So it takes 5.4 joules. If you send the image to the cloudlet, you are burning Wi-Fi energy in transmission, first hop. Of course, any additional hops are free in terms of energy, but your mobile device is still on, waiting for a reply. So as you notice, as you go further and wait longer for the result, the amount of energy consumed increases significantly. Now, hardware designers work very aggressively to try and optimize this, but they also have to trade off responsiveness, because when the reply packet arrives, you have to wake up your receiver from a deep sleep state, and essentially that adds to latency. So there's a fundamental trade-off between the aggressiveness of power savings and the crispness of user experience. And so consistently, not just for augmented reality, but for face recognition and all the other applications that we have explored, there is a very clear correlation between battery life extension and edge computing. Computing close by, offloading close by, can give you big wins in terms of savings. So I now want to move really far into the future. Someday, we hope there'll be lots of cloudlets around. How will this transform people's lives? Not in incremental ways, but in fundamental ways. I believe the opportunity lies in the following way. We happen to be living, by coincidence, at a time when three completely separate innovations, unrelated to each other, are all converging. So one of them is, of course, edge computing, which is why we're here. Completely independent of us, artificial intelligence in its numerous forms, computer vision, natural language processing, Skype now does language translation, okay, in real time. Google Goggles does translation for you. IBM's Watson in 2011 defeated the Jeopardy champion. So it's very clear. Things that were not conceivable a decade ago are really very good, highly accurate, but they're enormously resource intensive. You cannot do them on your smartphone, on your Google Glass, on your HoloLens. Anything you would want to carry with you or wear, you're not going to be able to do it. But the third innovation is the growth of wearable hardware of the kinds that I've mentioned. And I've just listed a few examples here. The number of companies is large. So the application that I see as a killer application lies at the intersection of all three, okay? So imagine this person wearing, in this case, Google Glass, but could be any of the other devices. It has a lot of sensors. It has a video camera, it's got a microphone, gyroscope, accelerometer. All of those are streamed over the wireless network to a cloudlet that is close by. And that cloudlet is powerful enough to do computer vision in real time, natural language processing, et cetera, et cetera. So what you have is a situation in which the algorithms on the cloudlet see what the user sees, hear what the user hears, sense what the user senses. If they can compute faster than the user can think, and perhaps whisper helpful guidance, that would transform human life. Imagine a person on the verge of being admitted to a nursing home because of Alzheimer's disease. Now, with the assistance of a device like this, you're able to recognize people better. You have helpful hints whispered in your ear to go through your daily life. There is evidence that even a 1-month delay in admitting people to a nursing home could save the United States $1 billion a year. That's a stunning figure. And of course, the quality of lives of those people and their caregivers is also better. So that's an assistive example. Let me show you some more practical things. You don't have to wait to grow old before edge computing can be valuable. It can help you even when you're very young. So here's a guy trying to cook. One of the earliest apps for Google Glass was being able to see recipes in your head-up display. So your hands were free, and this thing says the next step is heat 1 tablespoon of oil until it sizzles. Now, if you had a good friend standing next to this person, he or she might say, wait, don't put the stuff in yet. The oil is not sizzling. That is active guidance. Okay? Every one of you in this room has used a system like this, except you've never thought of it this way. Okay? Think of how a GPS navigation system works. Once upon a time, people who are old enough, like me, with gray hair, had to deal with paper maps. First question was, where am I on this map? And then, how do I get to where I want to go? It's a true test of your marriage. If you can survive many trips, okay, and not break up because of map interpretation. So GPS navigation has transformed that problem. It uses one sensor. It has deep knowledge of the task, and it gives you step-by-step guidance. If you make a mistake or ignore it, like you don't take the exit, it catches it right away and tells you what to do. At the next opportunity, make a legal U-turn. Could we generalize this metaphor? So I don't have time to go into the details of this. Over the last number of years, we've been working on a system called Gabriel, which you can think of as a platform as a service layered above the edge computing layer. So this would run on top of your cloudlet, effectively enabling you to use microservices on the cloudlet on behalf of your mobile device. Okay? So I will skip the details in the interest of getting through the rest of it. I want to show you a video, and I will let Jonathan here do the honors because we had to move this to a new laptop. Okay? So this is the world's first wearable cognitive assistant. We had to try something very simple. This is 2D Lego.
Once the task is loaded,
you're seeing the camera feed from Google Glass, what the user sees. And the little display on the top right is what is shown to him, and the voice is what he hears.
Welcome to the Lego task. As a first step, please find a piece of 1x4 green brick and put it on the board. Excellent. Now find a 1x1 white piece and add it to the top of the current model. Good job. Now find a 1x1 black piece and add it to the top right of the current model.
The really interesting question is, if he makes a mistake, will it find it?
Great. Now find a 1x2 white piece and add it to the top of the current model. Now find a 1x1 green piece and add it to the top left of the current model.
once you did something wrong, our system will tell you how to fix it.
slightly move the 1x1 green piece to the right by 1 brick size. Great. Now find
You
a
can
1
kill
by
it.
1 green piece and add it to the top left of the current model.
Okay. So what is going on is on each video frame, you are correcting for vision, lighting, angle of the user, et cetera, and extracting that matrix at the bottom right, which is like a analog to digital conversion in a very task-specific way, and you have to do this in real time. Now, that Lego did not seem so latency sensitive. So what? The guy might get bored a bit, but suppose you're trying to make a ping pong assistant.
Our Google Glass-based ping pong assistant helps the user to play better ping pong by whispering whether the user should hit to the left or to the right. The hint is based on the observed ball position and opponent position.
So the user who's playing, from whom you get this view, is wearing Google Glass and using a cloudlet over Wi-Fi. Okay? So it is basically in real time judging the direction of the ball, the direction of the opponent, and tells him where to hit.
We always guide the user to hit the ball
to the side which is harder to catch. Now, you might say playing ping pong is fine, but something that all of us have experienced is going to IKEA, buying one of those miserable kits, reading their printed directions, and making a mess. This is a real IKEA kit. Observe that when he takes that kit, the seal is unbroken.
In this application, our wearable system helps the user to assemble a piece of furniture. We are demonstrating using a real IKEA lamp. But instead of reading the instruction sheet, the user gets instructions from short video clips displayed on a smart glass. And our system provides appropriate feedback based on real-time analysis of user action.
Put the base on the table.
So now we have added video, which the user can see, tells him what to do, and then notes when he's done with this step.
Screw the pipe on top of the base. Good job. Now find the shade cover and expand it.
So can we have another minute or so? Okay. This won't take very long, but I'd like to get to the point where it actually tells him that he has made a mistake. So this is computer vision in real time. Okay?
Put the iron wires to support the shade, and show the top view of the shade.
As we can see, the system is able to accurately and quickly recognize a user's progress and provide appropriate video tutorial. The video tutorial will play repeatedly until the user finishes a step.
So the guy's made a mistake.
When the user makes a mistake, the system will quickly catch it and offer instructions to fix it.
You have attached one wire. Now find another one to support the shade.
So he had forgotten to put the other wire, and it told him that he didn't, and you can kill it. Okay, so the rest of it goes on, and he completes the whole thing, and there are no tears shed in the process. So think about this. Assembly. Think of a Weber, which makes grills. Any IKEA, many other companies. If you can reduce user error, returns, etc., frustration, you've dramatically simplified and improved your bottom line. A big part of industrial troubleshooting is expertise on the specifics of the machinery you're trying to repair. Siemens, GE, any of these companies that do industrial troubleshooting will find this enormously valuable. Medical training, look at that picture. That is a mannequin. Okay, it's not a human patient. Yet, that medical student needs a full-fledged, expensive doctor next to him to teach him how to examine the patient. Elder care, where, for example, you are taking your own blood pressure, etc., a big source of problems is people don't do it right. And as a result, the measurements are not useful. To the extent you can have an aid that guides you to do it right each time, especially if you're on the verge of senility, is very huge. And last but not least, imagine just as you're about to commit some unhealthy act, you have a cognitive assistant that tells you, no, don't do that. So the way to think about all of this is it has the look and feel and the latency intolerance of augmented reality, which people have thought of up to now as an entertainment, but it's combining in real time, in the inner loop of human cognition, faster than humans can think, the tools of AI. So it is the intersection of augmented reality and artificial intelligence with the human experience at the center of it. So I hope I've convinced you that while we have some distance to go before these kinds of applications are things we can count on every day and use every day, edge computing is indispensable. There's no way to do any of what I've showed you without edge computing, okay? And so in that sense, it's a truly disruptive technology. Thank you. Thank you.
Thank you, Satya. That was very fascinating and incredibly interesting to see those kinds of potential use cases that you really can't build without distributing computing power out closer to our users and to our customers. So that is our set of keynotes for the morning. A couple of points. We're going to break for lunch now, and the next set of breakout sessions will start at 12:45. Lunch, just go back out the way that you came in. And a couple people have already asked where I got this cool shirt and where they could get one. They will be on your way out, laid out by sizes. So if you want to get an OpenDev shirt on your way, grab that on the way out to lunch. Just before everybody runs off real quick. So when we come back from lunch, there will be three levels. So this is going to be level 1. And if you look at the schedule online at opendevconf.com, this is level 1. The stairs and elevator for level 2 are over there by the entrance. And the rest of the afternoon up until the last 45 minutes is going to be these working sessions. For the last 45 minutes, there will be a seminar in here from Satya again, where he'll present some other research and findings, and it'll be an opportunity to be more interactive and ask questions. And Steve from AT&T will be doing one level up, talking about some different mobile use cases. And again, presentation plus more interaction. So that's how we'll close out the day and then head to Wineworks. Before we break, does anybody have any questions about what to do today? Does everybody understand our assignments? Oh, I see a hand here. Beth. Yes, so there's a second level and a third level, and there are stairs and elevators over by the main entrance to the building.
Hey, John.
Yes.
Tell them about the directory where they can put their code.
Oh yeah, and one other point. So if you go to the schedule, there is a link there that will take you to an Etherpad. So throw ideas there for our unconference sessions tomorrow. And we've also heard that some of you want to be able to get in touch with each other. So there's an additional link in there to a Google Sheet. It's totally optional, but if you want to be able to get in touch with people or people to get in touch with you, you can just add whatever contact information you want in there. And we're just sharing that amongst our group. So that is it, and enjoy lunch, and we will see you back here this afternoon. Thank you.